e to the minus x times y equals 3 sine 2x. So let's have a go at this. We need to show that by differentiating this we obtain the differential equation y double dashed minus 2y dashed plus 5y equals 0. So let's differentiate then. Differentiating gives, so this is a product, so let's use the product rule here. So it's u dv dx plus v times du dx, which is a function of a function, e to the something differentiates to e to the something, multiplied by the something differentiated, which is minus 1, isn't it? Because that differentiates to minus 1. Differentiate this now. Sine differentiates to cos, so it's 3 lots of, so it's 3 times cosine of something, multiplied by the something differentiated, which is 2. So it's a function of a function. So that's what we've got there. So that's one time through. Let's just differentiate again. So we get some second derivatives appearing. So this is a product again, so it's u times the v, which is y double dashed, plus v times du, which is e to the something, differentiates to e to the something, multiplied by the something differentiated, which is that differentiates to minus 1. So that's that product differentiated plus, so we've got the second part of the product now, u, oh it's a minus isn't it here, so let's worry about that in a moment. We'll just write out these terms first of all. So it's u dv dx, e to the something goes to e to the something multiplied by the something differentiated, plus v e to the minus x times y dash du dx is y dashed. Now it's times through by minus, there's more than one term. So here's the two terms, and we said there was a minus at the front of that, didn't we? So let's put that in. Plus and a minus is a minus. So that's those two terms differentiated with the minus carried at the front. So we've got that, and that equals then, differentiate cos goes to minus sine. So, and another 2 comes out, doesn't it? So we've got 6 already, and another 2 makes 12. It's going to be sine of the something multiplied by the something differentiated, which is 2, and we've already put the 2 in by timesing it by the 6 to get 12. So that's that done. Now there's a minus here. There's a lot of minuses, but I'm just going to expand the bracket and see what happens now. So let's just expand the bracket. We've got e to the minus x y double dashed, e to the minus x y dashed, and what have we got in here? That's a minus. Let's just be careful here. And then we've got a plus because there's 2 minuses on the first term. When we expand this bracket, y e to the minus x, and then minus times a plus is a minus, e to the minus x times y dashed. So those are the 4 terms then. That's equal to minus 12. So let's just take the minus there and take 4 and leave the 3 with the sine 2x so that we can write e to the minus x times y instead. So that's what we've got. Now we can divide through by e to the minus x all the way through, can't we? So let's do that and just tidy it up. Okay, so let's divide by e to the minus x, if I can write it correctly without moving everything around. It's non-zero, never zero, so this is just going to be y double dashed. We've got this term and this term, so there's minus 2y dashes, aren't there? Then there's this term, but move this minus 4 over to be with it and we get plus 5. And there's nothing left to say, nothing left to put down, so we got 0. And that's what we wanted to show.